Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. So today we are going to discuss about the convolution and correlation of signals. This is the fourth unit in signals and system subject. For EEE students, it is a fourth unit of second part. And for the EC students, it is a fourth unit of first part. Okay. So for both second year EC students and the third year EEE students, we completed the 3 units fully. Now we entered into the fourth unit, the second part of the fourth unit for the third year EEE students, and first part of the fourth unit for second year EC students. Okay, my dear students. Actually, we have only the correlation of the signals only, but before knowing to the correlation, you have to know the convolution also. Okay, the convolution also, my dear students. So what is a convolution and what is a correlation and what is the relation between of convolution and the correlation of the signals? Okay. The first of all, what is a convolution? You see here the introduction of the convolution. Convolution, a mathematical way of convolution is a mathematical way of combining the two signals to form a third signal. Combining two signals to form a third signal. Convolution is important because it relates the input signal and impulse response of the system to the output of the system. So how the correlation means any system, that system having the impulse response h of t with the input signal x of t to get the response of y of t. It is a combination of the two signals. Convolution is a mathematical way of combining two signals x of t and h of t to form the third signal y of t. Convolution is important because it relates the input signal and impulse signal. The input signal x of t relates with the impulse signal h of t of the system to the output of the system y of t. Correlation is again a mathematical operation. See, up to this is a convolution. Okay, so what is the convolution formula? The y of t is equal to, is a combination of the two signals, the x of t with the convolution of h of t. It is not the into, my dear students, it's the asterisk. Call it as asterisk convolution between of the two signals. Now coming to the correlation. So correlation is again a mathematical operation that is similar to the convolution. Remember here, similar to the convolution. Correlation also uses two signals to form the third signal. It is very widely used in the practice, practically in communication engineering. It is very widely used in the practice, particularly in the communication engineering. Basically, it compares two signals. Correlation means correlated between the two signals. The name itself saying that is a correlation. Correlated between the two signals for the input signal and the impulse response signal. Okay, students. Basically, it compares two signals in order to determine the degree of similarity between them. Correlated, the degree of how far it is similar. Is a 90% similar or the 80% or the 50% is similar for the two signals. So actually the correlation is same as the convolution, but basically it is comparing of the two signals. Actually the uses of two signals to form a third signal. But here we are comparing the two signals to determine the degree of similarity between them. It is a very important point. Whenever if there has a, what is a correlation means comparing of the two signals to determine the degree of similarity between them. That is the definition of the correlation, my students. Okay. The examples, the radar, sonar, and the digital communications use correlation of signals very extensively. In the radar, sonar, and the digital communications use correlation of the signals very extensively. Correlation may be a cross correlation or auto correlation. As per your syllabus, from the J into K, we have only the correlation. There is no any convolution, my students. Okay. Correlation may be the two types again. Cross correlation and auto correlation. Cross correlation means the x of t is comparing with the h of t for the two different signals. Auto correlation means the same signals only. X of t and the x of t. The similar signals. Cross the two different signals, auto correlation. And it is the same signals. Same signals we are comparing them. First we are delivered the one signal and second time we delivered the same signal, but at the receiver side you have to compare these two signals, how far it is a degree of similarities between these two signals after the receiving end. Okay, my dear friends. Correlation may be cross correlation and auto correlation. When one signal is correlated with another signal to form a third signal, it is called cross correlation. If one signal is correlated with another signal, two different signals. When one signal is correlated with another signal to form a third signal, it is called cross correlation. Okay, my dear students. Now here, when a signal is correlated with itself, same signal, itself is auto, different cross. When the signal is correlated with itself to form another signal, it is called auto correlation. Here in the introduction part, we learn the what is correlation and what is a convolution and what are the two different types of correlation. The two types, auto correlation and the cross correlation. The cross correlation means when one signal is correlated with another signal to form a third signal is called cross correlation. The two different signals is comparing. When the signal is correlated with itself, the same signal is comparing with the same signal to form the another signal, it is called auto correlation. It is called auto correlation. Okay, my dear students. So in this chapter, the properties of convolution, convolution theorems associated with the Fourier transform and the graphical convolution of signals are to be discussed here. Also, the correlation, energy density spectrum, power density spectrum, Rayleigh's theorem, and Parseval's theorem are have to go for the discussion parts. The different types of the different topics we have to cover in this fourth unit as related to the convolution is convolution and the convolution theorems associated with the Fourier transformation and graphical convolution of the two signals, and correlation, energy spectrum, power spectrum, and Rayleigh's theorem and Parseval's theorem. These are the topics you have to go to discuss coming classes here. And the first one, you see what is a convolution, the concept of convolution. So this is a brief description about the fourth unit. So only the correlation, my students. There is many convolution as per your syllabus, but you have to learn. So what is a convolution? Without knowing the convolution, it is somewhat difficult to understood that correlation, because the same expressions, the mathematical expressions will get from the convolution only. Okay. So convolution is a mathematical operation which is used to express the input and output relation of a linear time invariant system. Which is used to express the input output relation of the linear time invariant system. It is the most important operation in the linear time invariant continuous time system. It relates input and impulse response of the system to output. Impulse response, think about the h of t, my dear students. Once again, I will explain the block diagram, the output y of t. It is relates input x of t and impulse response h of t of the system to output. An arbitrary driving function x of t can be expressed as continuous sum of impulse functions. The response y of t is then given by the continuous sum of the responses of various impulse components. Okay, an arbitrary driving function x of t can be expressed as a continuous sum of the impulse functions. The response y of t is then given by the continuous sum of the responses to various impulse components. So what is that formula here? The y of t is equal to when it is a continuous, we can represent it in the integral value, integral minus infinite to infinite, the x of tau h of t minus tau d tau, or it is also can express it as integral minus infinite to infinite h of tau x of t minus tau d tau. Can interchange x as h and h as x because it obeys a commutative property. What is a commutative property? Saying that AB is equal to BA. Commutative property. Okay, it's a continuous sum of the impulse functions. The x of t can be expressed as a continuous sum of impulse functions. The response y of t is then given by the continuous sum of responses of various impulse components. In fact, the convolution integral precisely expresses the response as a continuous sum of responses to individual impulse component. Let's see that one. So what is the equation we have here? So the x of t, y of t is equal to integral minus infinite to infinite x of tau, what I wrote here, delta of t minus tau. What is a delta of t minus tau is nothing but to get the impulse responses, the system can perform the operation on the impulse signal. Delta of t. Okay, the t of delta of t. So to get the impulse response, delta of t is passes through the system, the nothing but the linear time invariant system. To get the response is h of t. Okay, my dear students. Impulse signal, this one is an impulse response. So when it is a passes through the system, h of t is equal to t of delta of t. Some textbooks they are writing that is a f of or the t of, whatever the representation is there, same. Nothing is confusion, my dear students. So some textbooks are there denoted as a f and some textbooks are denoted as a t. When it is a pass, any signal is passes through the system. So they consider a linear time invariant system, which is initially relaxed at t is equal to 0. If the input of the system is an impulse. The input of the system is an impulse signal. Then the output of the system is denoted by h of t. Listen carefully, my dear students. If the input to the system is an impulse delta of t, then the output of the system is denoted as h of t and is called impulse response of the system. When it is output, when you consider as any output is a response only. Any output is a response. So when I'm teaching the subject, if I ask any questions, one of the students, one of your friend, he can answer the question means that is a response. A response for the what I asked the question. Follow my distance. Input is what I asked the question. What is the output? The response what you given to me. Okay, my dear students. The impulse response here, that denoted as h of t is equal to the t into delta of t. Because the delta of t, the signal is passes to the system, is represented as a t of. We know that any arbitrary signal x of t can be represented as any signal is multiplied with the delta function, you'll get the same signal. X of t is equal to integral minus infinite to infinite x of tau. The t and the tau is both are the same here. And the delta of t minus tau d tau. Okay, my dear student. As per the signal, any signal is multiplied according to the properties of the impulse function. Properties of a impulse function, x of tau, the delta of t minus tau d tau. Why I am taking the tau here means, you see, x of t delta of t is equal to x of t on. Why? At t is equal to 0 only, the delta of t is equal to 1. Okay, means here the x of t as x of 0. At t is equal to 0, the delta of t is a 1. That is also the x of t, nothing but is a 0 1. At the t is equal to 0. Suppose if it is shifted, delta function is shifted, x of t, delta of t minus tau is equal to, now it becomes of x of tau. Why it is x of tau? Now the delta of t minus tau is shifted with the samples of the tau. At the tau is equal to, okay, the t is equal to 0. Now the t is equal to tau function. The delta of t minus tau is 1. So in that case, x of tau is equal to x of tau 1. Okay, my dear students, any function is multiplied with the delta function or the shifted impulse function, you get the same function. So I represented this as x of tau integral t minus tau d tau with respect to the integral minus infinite to infinite. Even if we represent the integral minus infinite to infinite, delta function will get at t is equal to tau only. So the x of t is equal to the same thing. Okay, my dear students. And this total signal I am giving to the input as a x of t. As I am taking the x of t signal now, given to the system, to get the response is now the y of t. So what is the y of t? The t of what we return in the previous case, when the signal delta of t is given to the system, to get the response is the impulse response, h of t. Same way, the y of t is equal to t into x of t. T into x of t. Y of t is equal to t into x of t. What is x of t? The t of integral minus infinite to infinite x of tau delta of t minus tau d tau. So for a linear system, y of t is equal to integral minus infinite to infinite x of tau, the t of delta t minus tau d tau. because actual the input is a y of t is equal to the delta function. The delta function is a varying the t minus t tau or something. So the t of delta of t minus tau. What is the h of t is equal to t of delta of t? Instead of t, now it is a t minus tau. It becomes of h of t minus tau. Okay, my dear students, if the response of the system due to the impulse signal delta of t is h of t, then the response of the system due to the delayed, the impulse response is h of t comma tau, that is a t of delta of t minus tau. You can replace that t of delta of t minus tau as h of t minus tau theta. So finally, the convolution equation derived as y of t is equal to integral minus infinite to infinite x of tau h of t minus tau d tau. This is called convolution integral or simply convolution. The convolution of two signals x of t, y of t can be represented as y of t is equal to x of t with, this is a symbol of convolution, my student, asterisk we can call it as x of t with the convolution of h of t. In general, the lower and upper limits of integration in the convolution integral depends on whether the signal x of t and the impulse response h of t are causal or not. What is a causal? We know causal means it is depends upon the present and the past inputs. Non-causal means it is depends upon the future input. If h of t is a causal, then h of t minus tau is equal to 0. If h of t is a causal, then the h of t minus tau is equal to 0 for tau is greater than the t. Tau is greater than the t. Therefore, the upper limit of the integration is a t for a causal h of t. If x of t is a causal, then x of t is equal to 0 for t less than the 0. Therefore, the lower limit of the integration is 0 for a causal x of t. Understood, my dear students? Upper limit of the integration is a t and the lower limit integration is a 0 here. So 0 to t only the total output will get when it is a causal system. When you are saying it is a causal system, the upper limit you have to take as a t and lower limit as a 0 with the signals of x of t and the h of t. Following, my dear students. There's a very important derivation part to find the output response with the signals x of t, the input signal x of tau, and the delay version of impulse response with the tau. So x of tau h of t minus tau d tau with the integral minus infinite to infinite y of t is convolution for continuous time system, because all it is a t functions. Following, my dear friends. See, the y of t is equal to integral minus infinite to infinite x of tau h of t minus tau d tau. If both x of t and h of t are non-causal, when it is a causal, x of t is a non-causal and h of t is a causal, minus infinite to t. See, the t, upper limit is a t means h of t is a causal. But here it is a 0, then x of t is a causal. So x of t is a non-causal means minus infinite to t. Both the non-causal means minus infinite to infinite. If only the x of t is non-causal and h of t is a causal means the change of limitation is minus infinite to the t. Okay, what we discussed in the previous slide. You see here, the upper limit of integration is a t for a causal h of t. If x of t is a causal, the lower limit is a 0. Okay, my dear students. So here the upper limit is a t. Now h of t is a causal and x of t is a non-causal. So lower limit of I am taking the 0 and infinite, x of t is a causal and h of t is a non-causal. And the total signal is a causal when the limitations is changes from 0 to t. Remember, my dear students. Is also it is very important in the online examinations. If the given lower limit and the upper limit minus infinite to infinite, both the signals non-causal. If the lower limit is a minus infinite, upper limit is a t, means x of t is a non-causal and h of t is a causal. And the lower limit is a 0 and upper limit is a infinite. So x of t is a causal and h of t is a non-causal. And the limitations is changes from minus infinite to infinite as a 0 to t. X of tau, h of t minus tau d tau if both x of t, h of t are causal. Means it is depends upon only the present and the past inputs only. When we can take it from the 0 to t, the limitations. Okay. Now coming to the properties. Properties of convolution. Properties of convolution. Let us consider the two signals x1 of t and the x2 of t. As I assume here the h. Now I take that as x as x of x1 of t and h as a x2 of t. So the formula, according to the formula, the convolution of the two signals x1 of t and the x2 of t is given by x1 of t with the asterisk of x2 of t. The formula, the integral minus infinite to infinite x1 of tau instead of h. Now I am taking the x2 of t minus tau d tau. Remember this, my students. Simply remember this equation. Okay. Or you have to by it simply. Any signal you have to given. The first signal is tau. The second signal in the parenthesis is a t minus tau, and we are applying the derivative with respect to the tau. Is equal to the t. See the t function is y of t is equal to here the t, the remaining all is a tau only. Two functions. Or otherwise, integral minus infinite to infinite x2 of tau, x1 of t minus tau d tau. In the first slide, I explained that it is a convolution obeys the commutative property. Convolution obeys the commutative property. AB is equal to BA. Interchanging of x1 and x2 here. x2 of tau, x1 of t minus tau. Both the resultant value is the same. Even if you have the interchange of the x1 and x2 also, the resultant value is the same only. The properties is the first property. The commutative property of convolution states that x1 of t convolution of x2 of t is equal to x2 of t with the convolution of x1 of t. Both are the same. Distributive property. The distributive property of convolution states that x1 of t with the convolution of, if I am taking the x2 of t plus x3 of t, adding of the two functions. Individually, x1 of t convolution x2 of t plus x1 of t with the convolution of x3 of t. x1 is distributed to these two signals. It is also obeys. Distributive property is also obeys the convolution. So coming to the associative property, x1 of t with the convolution of x2 of t, convolution of x3 of t, a into bc is equal to ab into c. Okay, my dear students. Actually, the commutative property means we know the equations are AB is equal to B. And coming here, A into B plus C. So A is the x1 here, B is x2, C is the x3. AB into BC is equal to AB plus AC. And associative property is A into B into C. So A is x1, B is x2, and C is x3 is equal to AB into C. Okay, all the resultant value is the same, my students. Okay. And another property, the first one, commutative property, distributive property, associative property, and shift property. The shift property of convolution states that if x1 of t convolution of x2 of t is equal to z of t, so x1 of t with the convolution of x2 of t minus t, the second signal is shifted with the t samples, the output is also shifted with the t samples. So even if it is the first signal is also delayed with the t samples, the output is also delayed with the t samples. It's a time invariant. The input is delayed with the tau samples, the output is also delayed, and we can call it as a time invariant. If the input is delayed, the output is not at all the delayed, the function, nothing but time variant signals. Okay. So any one signal is delayed, the output is also delayed here, but both the signals is delayed. x1 of t minus t1 with the convolution of x2 of t minus t2, the output is delayed with the sum of the two delay functions, minus of t1 plus t2. Okay, the t1 plus t2 you have to add, and that number of samples is shifted in the output side. Set it of t minus t1, t minus t1 minus t2. Okay, my dear students. So totally the 5 properties of the convolution: commutative property, distributive property, associative property, and shifting property, or the shift property. Okay, my dear students. Next one, the convolution with an impulse. That is another property, my dear students. Here, convolution with an impulse. I already told any signal is with the impulse function, you get the same signal. Convolution of signal x of t with the unit impulse is the signal itself, that is x of t with the convolution of delta of t. Again, we will get the x of t on. Okay. And that's a width property. Let the duration of x1 of t and x2 of t be the t1 and t2 respectively. Then the duration of the signal obtained by convolution of x1 of t and the x2 of t is a t1 plus t2. What we explained in the previously is a delayed functions, the duration. Delayed of the t1 samples and delayed of the t2 samples of the two signals x1 and x2 is obtained. The convolution is the t1 plus the t2, the duration part. Okay. Now, some examples of the convolution. Let x1 of t is e power minus 2t mu of t, and x2 of t is e power minus 4t mu of t. The first example, my students. First example, e power minus 2t mu of t and e power minus 4t mu of t. Find the convolution. Convolution is a y of t is equal to the convolution between the two functions. I will explain the code here, my dear students. The example is given. The first example, let x1 of t e power minus 2t mu of t and x2 of t is given e power minus 4t mu of t. Okay, my dear students. So what is a convolution equation? As I'm taking that y of t is equal to the convolution of the two signals x1 of t with the convolution of x2 of t. The formula is integral minus infinite to infinite x1 of tau, x2 of t minus tau d tau. Okay. Now what is the x1 of tau given it is a e power minus 2t mu of t. Now I'm changing is x1 of tau here. So e power minus 2 tau mu of tau as x1 here. What is the x2 of t minus tau? But the given e power minus 4t. So I change this as a e power minus 4 into, instead of t here, the t minus tau in the formula, mu of t minus tau into d tau. Okay, students. The given functions x1 and x2, according to the convolution formula, integral minus infinite to infinite x1 of tau, x2 of t minus tau, d tau. I substituted according to this formula, as the t is, instead of t, they replace the tau. Instead of t, here they replace the t minus tau, is equal to integral minus infinite to infinite e power minus 2 tau into e power minus 4t into e power minus into minus is a plus 4 tau. I split the two parts, and the remaining here the mu of tau and the mu of t minus tau. Two functions, the step functions, and d tau. So mu of, and this also mu of. So mu of. Okay, my dear students. So before you have to substitute the mu of tau and the mu of t minus tau. What is the values here? Mu of tau is equal to 1 for tau is greater than or equal to 0. Okay, my dear students. So the tau, whatever the tau we have inside the parenthesis, is greater than or equal to 0. Okay. Similarly, the mu of, after the shifting of the samples, t minus tau is equal to 1 when the t minus tau is greater than or equal to 0. Okay, students. The step function is from 0 to infinite, positive values is a 1, and mu of t minus tau, mu of t minus tau is also 1 for the t minus tau is equal to greater than or equal to 0. Using these two relations, tau is greater than or equal to 0, and another thing, the t minus tau, if I take that, is after greater than or equal to t greater than or equal to tau. And what is the tau here? Tau is less than or equal to t. Now, tau is greater than or equal to 0 and tau is less than or equal to t. Combine these two relations. Now I am taking the 0. Tau is 0 less than or equal to, and it is a less than or equal to t. So after the combining the two relations, so 0 less than or equal to tau means tau is greater than or equal to 0. Tau is less than or equal to t. So the tau is varies from 0 to t. Now it is a causal system. So minus infinite to infinite means non-causal of the two signals. When the upper limit is changes as a t, the second signal is a causal, and lower limit is a 0. The first signal is causal. If both are changes, the system, the signal is a y of the output signal is a causal signal. Now, what is a, when substituting the mu of tau is 1 and the mu of t minus tau is a 1, with these two functions, change the limitations as 0 to t. Lower value is a 0 and upper value is a t. Okay, 0 to, now the y of t. Y of t is equal to, our lower limit is a 0, upper limit is a t. What is the equations here? E power minus 4t is there. We are applying the derivative integral with respect to the tau only, my dear students. I am writing the e power minus 4t is a constant, and the two functions are the e power minus 2 tau and e power plus 4 tau. Add the functions because the bases are the same. 4 tau minus 2 tau into d tau. Okay, I'm not writing the mu of tau and the mu of t minus tau. Change the limitations here by substituting the two ranges here, that tau is greater than or equal to 0 and tau is less than or equal to t. Okay, my dear students, is equal to e power minus 4t is a constant, and the e power integral 0 to t, that is the e power 2 tau into d tau, is equal to e power minus 4t. Apply the integral for 2 tau, e power 2 tau by 2, with upper limit is a t and lower limit is a 0, is equal to e power minus 4t, substituting the tau as a t, e power 2t minus e power 2 0, nothing but is a e power 0, 1 by 2. Okay, my dear students. Now you can multiply this one, multiply, final answer I will write here. What is the y of t? The y of t is equal to, multiply these two functions, e power minus 4t and e power 2t. Bases are same, you can add the powers. Minus is a greater value, so e power minus 2t is equal to e power minus 2t, and 1 into e power minus 4 minus e power minus 4t by 2. Okay, my dear students, so this is a y of t is equal to e power minus 2t minus e power minus 4t by 2 is a convolution of the given two signals x1 of t and the x2 of t. E power minus 2t minus e power minus 4t by 2. All right. See what we got, the same thing here, the e power minus 2t minus e power minus 4t by 2 into mu of t. Why it is into mu of t? Again, it is in the positive real axis only, my dear students. It is multiplied with the mu of t on. The given two signals is multiplied with the mu of t. The output is also multiplied with the same signal. See the ranges I wrote here, the mu of tau is equal to 1, tau is greater than or equal to 0, and mu of t minus tau is equal to 1, the t minus tau is greater than or equal to 0. For tau is less than or equal to t, the range is 0 less than or equal to tau less than or equal to t. So convolution is becomes of minus infinity infinity as 0 to t, e power minus 2t, e power minus 4t minus e power minus 4t. E power minus 4t is a constant. Apply the e power 2 tau d tau. E power 2 tau d tau with upper limit is t and the lower limit is 0. Substitute the e power minus 2t and e power minus 4t by 2 for t is greater than or equal to 0 only. T is greater than or equal to 0. So it is a mu of t. Okay, my dear students. The similar way, you can take a second example also. X1 of t is a t into mu of t and x2 of t is also the t into mu of t. Both are the same, my dear students. But the convolution formula, the x1 of t convolute with the x2 of t, integral minus infinity infinite x1 of tau, x2 of t minus tau d tau. What is the x1 of tau? T into mu of t. So change t as a tau, tau into mu of tau. And in the second signal, change the t as a t minus tau. So t minus tau, mu of t minus tau d tau. Again here the mu of tau and the mu of t minus tau. Change the limitations minus infinity infinite, again 0 to t only. Okay. Any confusion, my dear students here? So I am replacing the mu of tau and the mu of t minus tau as a 1 by changing the limitations as 0 to t, converting into the causal function. Okay. So integral 0 to t x of t minus tau d tau. X of not that x of, my dear students, t of. You see the tau of the tau of t minus tau. So mu of tau is 1 and the mu of t minus tau is 1. Tau of t minus tau. Tau of t minus tau. Okay. What is with respect to, we are applying the integral with respect to the tau only. So multiply the two functions here. Tau into t d tau minus tau into tau is the tau square d tau. T is a constant, you put it is outside. Integral tau is a tau square by 2 and integral tau square is tau cube by 3. So integral anything is n plus 1 by n plus 1 minus students. So t into, now upper limit is a t and lower limit is a 0, t square by 2 minus 0 minus, and here the tau cube is there by 3, upper limit is a t cube by 3 minus 0. Simplify this one, t square by 2 into t, that is a t cube by 2, here the 0 minus t cube by 3. So numerator having both the functions is a t cube only. Take the t cube as a common, 1 by 2 minus 1 by 3. 1 by 2 minus 1 by 3 minus 2. So what is a 1 by 2 minus 1 by 3? 1 by 2 minus 1 by 3 is a 3 minus 1, 2 by 6. That is a 1 by 6 minus students. So t cube by 6 for t is greater than or equal to 0. Therefore, the convolution x1 of t and x2 of t, the t cube by 6 into mu of t. T cube by 6 into mu of t. Okay. And coming to the third one, third example, see, my dear students, for the convolution. What they given x1 of t is a cos t mu of t and x2 of t is a mu of t. X2 of t is a mu of t, my dear students. So I will explain here the cos t mu of t. Cos t mu of t, x2 of t is a mu of t. So third example, x1 of t given as cos t mu of t and x2 of t is a mu of t. The two signals, my dear students. Okay. Now I have to find out y of t, the convolution of the two signals. Integral minus infinity to infinite x1 of tau, x2 of t minus tau d tau. What is the x1 of t is given cos t mu of t. Change the cos t mu of t as a tau values, cos tau mu of tau, and x2 of t is a mu of t. So mu of t minus tau d tau. Okay, we know the mu of tau and the mu of t minus tau, changing the one value with the range of 0 less than or equal to tau less than or equal to t, my dear students. So using these limitations of 0 to t, cos tau d tau. Because I am keeping that the mu of tau and the mu of t minus tau is equal to 1. With the limitations is changes from 0 to t. Okay. So what is a cos tau sin tau? With the upper limit is a t, lower limit is a 0. Therefore sin t minus sin 0. It becomes of sin t. Sin 0 is a 0, my dear students. So y of t is equal to So y of t is equal to sine t into mu of t, because the signal is t is greater than only sine t into mu of t. So we got cos t is sine t into mu of t. Okay, my dear friends. Therefore, the x1 of t with the convolution of x2 of t is the sine t mu of t. The integral of cos is a sine, upper limit is t and lower limit is a 0. Lower limit sine 0 is a 0. And similarly, the fourth example you can see. Given x1 of t is equal to e power minus 3t mu of t, x2 of t is equal to mu of t plus 3, my dear students. Mu of t plus 3. Now the limitations is changed. So I will explain this one. E power minus 3 mu of t and e power mu plus x2 of t is a mu of t plus 3. E power minus 3t mu of t, e power minus 3 mu of t, and another one is a mu of t plus 3. Okay, these are the two functions is given, the two signals is given. X2 of t is equal to and x1 of t minus 2. Okay, another example. Now using these two signals, you have to find out the convolution of the two signals. So y of t is equal to integral minus infinite to infinite x1 of tau x2 of t minus tau theta. Okay, what is the x1 given? E power minus 3 mu of t. So the e power minus 3 tau mu of tau. Okay, as x1, and x2 mu of t plus 3. But instead of t here, the t minus tau mu of t minus tau plus 3. So replace the t as the tau here, that replace the t as the t minus tau into theta. Okay. Now, integral minus infinite to infinite e power minus 3 tau mu of tau and the mu of t plus 3 minus tau theta. Now we know the mu of tau is equal to 1 for tau is greater than or equal to 0. One relation. Similar way, the mu of t plus 3 minus tau is also equal to 1 for the total function. What is the function here? The t plus 3 minus tau is greater than or equal to 0. And t plus 3 is greater than or equal to tau. So from left hand side to the right hand side, take the minus as a plus. And what is a tau? The one relation is that tau is greater than or equal to 0. And the tau is t plus 3 is greater than means tau is less than or equal to t plus 3. Two relations we got. Combine these two relations as tau greater than means it is a less than or equal to 0, less than or equal to t plus 3. So from 0 to t plus 3 is varies. Change the limitations. Now the y of t is equal to integral 0 and the t plus 3 e power minus 3 tau theta. Okay. The mu of tau and the mu of t plus 3 minus tau is a 1. Apply the integral e power minus 3 tau by minus 3, upper limit t plus 3, lower limit is a 0. And coming to here, substitute the e power minus 3, tau is a t plus 3, minus e power 0 whole divided by minus 3. So therefore y of t is equal to e power minus 3 into t plus 3 minus 1 by the minus 3. So y of t is equal to, or you can multiply the minus of 1 by 3, 1 minus e power minus 3 into t plus 3 by 3. Okay. So see here. So 1 minus e power minus 3 into t plus 3 by 3. We got it is a e power minus 3 of t plus 3 minus 1 by minus 3. Now it is a t is greater than or equal to minus 3. So y of t is equal to, for t is less than minus 3, the value is a 0. You take only the greater than the minus 3, greater than the minus 3 values. Okay, my dear students. And coming to the last one, what the 5 examples we are given there, we find the e power minus 2t mu of t and e power minus 4t mu of t and t into mu of t and t into mu of t, cos t mu of t and mu of t, and e power minus 3t mu of t and mu of t plus 3. Now the last one, given x1 of t is r of t and x2 of t e power minus 2t mu of t. The convolution r of t, that is a t into mu of t in terms of the step function. x2 of t is equal to e power minus 2t mu of t. Okay, r of t is nothing but t into mu of t only. How the ramp function linearly it increases from 0 to infinite, my students. That is a t only. And the t is equal to 0, the r of t is also 0. And t is equal to 1, the r of t is 1. The t is equal to 2, the r of t is a 2. T is equal to 3, the r of t is a 3. R of t is equal to. So r of t is a t into mu of t. Okay, my dear students. So r of t given as a t into mu of t, the second function is e power minus 2t into mu of t. Okay. T into mu of t and e power minus 2t mu of t. Let's do that one also. T into mu of t and e power minus 2t. Another example, x1 of t is equal to, as r of t is t into mu of t and another signal x2 of t e power minus 2t mu of t. Okay, is it right? E power minus 2t mu of t. Now, to find this another example, the last fifth one, y of t is equal to, as a formula saying that integral minus infinite to infinite, x1 of tau, x2 of t minus tau d tau is equal to integral minus infinite to infinite. Change as the first one as a t into mu of t as tau into mu of tau as x1. What is the x2? E power minus 2 into t as a t minus tau and mu of t minus tau into d tau. And rewrite this expression as integral minus infinite to infinite, the tau e power minus 2t into e power 2 tau into mu of tau, mu of t minus tau d tau. We already know the mu of tau and the mu of t minus tau. Substitute the 1 here and change the limitations minus infinite to infinite as a 0 to t. 0 to t tau into e power 2t, not the 2t, sorry, 2 tau, and e power minus 2t into d tau. Since the integral is with respect to the tau, the e power minus 2t is a constant, my students. Constant. So y of t is equal to, take the constant is outside, the e power minus 2t, integral 0 to t, tau into e power 2 tau. Now apply the integration by parts into d tau. What is the integration by parts here? The y of t is equal to e power minus 2t as multiplied with tau. Apply the integral here. E power 2 tau by 2 minus, take the integral, and the tau derivative is a 1. Apply the integral, e power 2 tau by 2 into d tau, with the limitations is a 0 to t. Next, e power minus 2t, tau e power 2 tau by 2 minus, again apply the integral of e power 2 tau as 1 by 4 into 1 by 4 into e power 2 tau, because already the 1 by 2 is there. Now the e power 2 tau is a e power 2 tau by 2, 2 into 2 is a 4. So lower limit is a t and upper limit is a t. Lower limit is a 0 and upper limit is a t. So take the e power minus 2t is a multiplication factor here. Substitute the upper limit now first of all. Tau is a t, e power 2 tau by 2 minus 1 by 4. It is not the tau, my dear students, it is also the t only. 2t minus 1 by 4, 2t. That is upper limit of the two terms. Lower limit is a minus, take the minus to substitute the 0. The 0, the first term is a 0, and the minus into minus is a plus. 1 by 4 into e power 0 is a 1. 1 by 4 here. Okay, my dear students. That is equal to y of t is equal to, after simplify, e power minus 2t can multiply here, t by 2 into e power minus 2t and the e power plus 2t. What did we have value? E power 0. So e power 0 is a 1. 1 minus, again 1 by 4 into e power 2t and e power minus 2t. That is value is a 1 only. E power 0. Now this e power minus 2t is also multiplied with 1 by 4. So plus 1 by 4 into e power minus 2t. The final expression of the y of t is 1 by 2 into t minus 1 by 4 plus 1 by 4 into e power minus 2t. See that? The final answer will get here t by 2 minus 1 by 4 plus e power minus 2t by 4 into mu of t. Because it is a t is greater than or equal to 0, my dear students. T by 2 we got minus 1 by 4. T by 2 minus 1 by 4 plus 1 by 4 into e power minus 2t. 1 by 4 into e power minus 2t. 1 by 4 into e power minus 2t into mu of t. Okay, my dear students. There is a 5 examples we did in the convolution, and we discussed some of the properties of the convolution: commutative property, distributive property, and associative property, and the shift property also. And when it is a non-causal, and when it is a non-causal and the causal, and when it is a causal for both the signals, changes of the limitations, and the derivation part of the convolution. Okay. And the tomorrow class, we can see the convolution theorems, time convolution theorem and the frequency convolution theorem. Okay, my dear students. So any doubts? Please rise. Thank you.